All right, Chapter 5, Problem 14. We have a car on a 4-degree slope, and they want us to calculate what its maximum acceleration is under 3 different conditions. One is dry concrete, one is wet concrete, and the other is ice. Because I looked it up, I know that mu s for rubber on dry concrete is 1.0. All right, so in part A, mu s is 1.0. We also know that the frictional force, maximum frictional force, right, is mu s, and so this would correspond to the maximum acceleration, the maximum force you can exert without breaking static friction is mu s times n. Okay. Now, what is the normal force in this case? One, we have a 4-degree slope, right? And the car is sitting here on a 4-degree slope. Two, they tell us we're dealing with just the front wheels and only half the car's weight is on the front wheels. So if you look carefully at this slope, right? Here's a wheel. Half the car's weight is coming down this way. But the normal force, if you'll remember, is the force straight into the slope. Well, it is a 4-degree slope, right? That 4 degrees is also the angle there. So the maximum force has a cosine of 4 degrees in it. So this is the normal force, let me just pull it out by itself. The normal force equals 1/2 of the weight, which is the mass times acceleration and gravity, because half of the weight is on the front wheels, times cosine of 4 degrees. All right, cosine of that angle, cosine of 4 degrees. All right, so I'm going to write all of that down. I'm going to write the maximum frictional force is mu s times 1/2 mg cosine 4 degrees. Or, if you want to clean it up just a little bit, equals 1/2 of mu s mg cosine 4 degrees. Okay. Now, you're probably thinking, well, what about the mass? All right, but from Newton's second law, right, F net equals mass times acceleration. What is F net in this case? F net is Fs, right? F net is Fs. So when we want the maximum acceleration, we have ma equals 1/2 mu s mg cosine of 4 degrees. The m's cancel out on both sides, and we get that the maximum acceleration A is 1/2 mu s g cosine 4 degrees. All right. Now, what does this mean on wet concrete? On wet concrete, this is 1/2 of 1 times 9.8 meters per second squared times cosine of 4 degrees equals, pop over to Excel, all right, equals 1.5 times 9.8 times cosine of degree of radians of 4 degrees. So 4.88 or 4.89 meters per second squared. All right. All right. So part B. All right. Because I kept everything in symbols as far as I did, part B is easy. We just take this same equation. All right. We look up mu s for rubber on wet concrete. It turns out to be 0.7. All right, so I'm going to take 0.5 times 0.7 times 9.8 times the cosine of the radians of 4 degrees. All right, 3.42. 3.42 meters per second squared. And finally, for part C, all right, part C, exactly the same set of equations, except now mu sub s is 0.1, right? So equals 0.5 times 0.1 times 9.8 times the cosine of the radians of 4 degrees is 0.49 or 0.489. So let me just move a decimal point, 0.489, right? And that's it for problem 14. There you go.